Welcome to Losi Motorsports. Here with Don, I'm Richard, and we finally have things all settled up, I believe, on this LS3 swap. So we ran into a couple of issues.
Yeah, DTCs.
Yeah, so what were the DTCs that we got?
We ended up with a wideband O2 lean condition, as well as exceeding a duty cycle on an injector.
Correct, exactly. So originally, the way the fuel system worked is it had this style of fuel rail.
And if you see
the way the fuel,
the driver's side entry.
Yeah, so the fuel would end up coming from here, and then after that, as it gets used up, this is where the injectors are. So it was actually sitting like this onto the motor, right? So this is the way that it was. Now, the one thing which is also very important is that when you have it sitting like this, the way we had it is the fuel was here, and it was actually coming right down here, the back of the motor. And unfortunately, it crossed the header right there. And then after that went all the way to the back of the car. And here's an example of the way it was.
Oh, just before you go there.
Oh,
before you go there. The car as designed from Subaru has the fuel line on the driver's side. And so we thought it was going to be just peachy for us to be able to get the fuel line to connect on the driver's side for the LS3. And so the routing wasn't necessarily something that we considered to be an issue. We just said, hey, you know what? If Subaru was able to do it, well, we'll just kind of, use the same routing essentially. The Subaru has a deadheaded system as well, but it's two lines so that they can supply, either side of the engine. With this one here on the LS3, it's deadheaded as well because there's just one entry and no return. And what that causes, and this is the issue that we were dealing with, is that the fuel running in that line is not running fast enough. And so as it runs near the header, it actually accumulates a lot of heat. And as a result, we get wideband O2 lean conditions, and we get injector duty cycles being exceeded. So now, to remedy that, we had to move the fuel line.
Yes, so one of the things also which is important to note is, before we go down that road of how we fixed it, is if you look at here, the way that it actually ran from the front, it ran all the way back there here, and then it came to the regulator. And from the regulator, it ended up going from there to the return on the fuel cell. And then of course, this used to be turned around the other way where the pump was here, and it would pump and then go to the front to here, all the way to the entry on the fuel rail. The problem that happened with that is because the return is actually here, this is the return line, because of that, what happens is the fuel here gets recirculated just here, but everything from this side all the way to the front stays there until it's consumed by the motor. So as Don was saying, is that basically the fuel is actually here all the way to the back to the fuel cell was just sitting there. So it accumulates heat and causes what Don was actually talking about. So the way we remedy it is a completely different way of doing things, where now the fuel actually runs front to back without being deadheaded. Meaning, if you look at it here, the fuel comes from the fuel cell, it comes into a fuel filter, goes into a fuel pump, it goes out here, and I'll show you on the car here, what we did is the fuel line ends up coming down here. So to see this tube, because it runs in cabin, it's very, very critical that it runs inside of a tube, just so that you're not exposing the cabin to gas. That would be very, very dangerous, so you can't do that. So we have it encased inside of this tube that runs all the way to the front. And you can see here down inside, it goes there, and then comes out here. So it comes out there, and you'll notice there's actually two lines, right? There's one of the lines that comes here, right here. This is the one coming from the fuel tank. Comes here into the front of the injector. We have the fuel pressure monitor here. It comes into the injector rail, the fuel rail, comes across on the back here, you can see, comes all the way here, and then after that comes to the regulator. Then after that, from the bottom of the regulator, so this is all 8N, and then underneath the regulator, we have the return. So the return is the other line that goes from here, goes all the way to the back, through that pipe, and then goes to return on the fuel cell. So the big difference between the two systems is the fuel regulator here is after the rail, and the other one, the regulator was at the back, right at the tank. The big advantages doing it this way is...
Well, from a pressure regulation perspective, when we had the old system, what we were seeing on our fuel pressure traces was that we were seeing some, say, 60, 65, 70 PSI that would dip all the way down to 19. And so the regulation, I don't know if it was actually a problem with the regulator itself, but it just seemed like there was a lot of pressure variation. And with this arrangement, because we're actually pumping into the header, from the pump itself and regulating the flow back to the return, it's keeping a much more constant 60 PSI on the fuel rail. And so, we have the gauge here, and we've set the regulator up, and we've monitored it as we, kind of done some short runs here, and it seems very, very steady. So that's an advantage of having the regulator after the fuel rail, essentially.
Yep.
So.
And also it's also a lot cooler to the touch, eh? The fuel rails now?
Yeah, well, because it's always circulating fuel, the heat buildup is insignificant, really, because it doesn't reside in the engine bay for any length of time. And so your heat sink, which is really your fuel cell, there's a lot of fuel in there that basically just moderates the temperature coming, through to the engine and returning. So we don't have any of that problem anymore. So the DTC codes have disappeared, as far as, lean conditions are concerned. So overall, it was a good fix. We'd recommend that people do that if they're thinking about tracking their car. Simply because running your fuel line on the driver's side, could net you some problems, as time goes on. I'm not sure what it would do on a street car, essentially, whether, you'd ever, kind of have that kind of condition if you're not wide open throttle and that kind of stuff. But, for us, it was throwing some codes. So, yeah.
Perfect.